Now I want to revisit the situation that you are on the end of my string, and I'm going to swirl you around. Earlier I swirled you around like this, and you didn't like it, and I don't blame you because you got dizzy. Now I'm going to rotate you like this. You may like that better. Maybe not. And so, whether you like it or not, I'm going to twirl you around, and here you are. This is the circle. There's a string. You're here. Here's the string. And there you are. You have a certain velocity. The velocity is in this direction. And there is a certain distance to the center, r. And so you need a certain centripetal acceleration to go around in that curve. So you need a centripetal acceleration, A of c, which is, you can take the v squared divided by r, if you like that. This is the magnitude of that v. Now follow me very closely. Just imagine that this number happens to be exactly 9.8. I can always do that. Where is this person going to get the push or the pull from for this centripetal acceleration? Does the string have to pull on it? No, because there's always gravity, and gravity gives you an acceleration of 9.8 meters per second squared. So the string says, tough luck, I don't have to do anything. Gravity provides me with the 9.8 meters per second square that I required. Now I'm going to swing you faster. So the v will go up, and so the centripetal acceleration will go up. The string will say, aha, I'm going to pull now on this person. Because the gravitational acceleration alone is not enough. I need some extra pull. So the string is going to tighten and pull on you. And I say, hello there, in what direction is gravity? And you say, gravity is in this direction. Why? Because you feel the string is pulling on you in this direction. So you experience gravity there. Now comes the question, how real is this? This is very, very real. It is so real that if I took a bucket of water instead of you, and here is the bucket of water, I attached to the bucket a rope, I swing it around, and I swing it around such that the centripetal acceleration is substantially larger than 9.8. So the string is definitely going to pull. So if you were the water, and I asked you where is gravity, you would say the gravitational direction is in this direction. And so the water will say, okay, fine. Then this will be my surface, and I want to go in this direction. But the water can't go in that direction, so it will just stay there. So I could swing this thing around, if I do it fast enough, so fast that the acceleration at this point here must be larger than 9.8. The water will stay up while the bucket is upside down. How fast should I rotate it? Well, let's put in some simple numbers. I have here this bucket, and let's say that this is about 1 meter. I'll just round some numbers off. So r is about 1 meter. And I want v squared over r, I want that to be larger than 9.8. Let's just call it 10. So that means v has to be larger than about 3.2 meters per second. The time to go around is 2 pi r divided by this velocity. So this time to go around then has to be less than 2 seconds. So if I swing this around in less than 2 seconds, I would be okay. Now I realize that the speed when I move this thing around is not constant everywhere. That's very difficult to do that because of gravity. But it's close enough to get an idea. So if I rotate this faster than in 2 seconds, when the bucket is upside down, if physics works, the water should not fall out. So let us fill this with water. There we go. Yeah, you're doing the right thing there. I don't blame you at all. Okay. There we go. You see the water is completely full. And notice that I go around substantially faster than in 2 seconds. And the water, when it's up there, just thinks that gravity is towards the ceiling. Physics works. Now, who is going to do this for me, too? Please, someone should try this. You think you can do it? Come on, try it. In the worst case, it will be a disaster. Okay, get some feel for it, but before you do it, make sure that I'm out of the way. So first, swing it a little, and don't hold it too close to you, because I don't want you to get hurt. Larger swing, larger, larger. And then you get some feel for it. Go for it, now! Yeah, faster! That was very good. See you Friday.